In this lecture, I'm going to be talking to you about password security. Remember that I said that social media is a great platform for information sharing, and therefore we need to take measures to protect that information from people who might use it in ways that we do not want them to. Passwords are important for social networks because they are the first line of defense. Without a password, in fact, anybody could get access to your social network or to your social media, whatever form it represents, and do things on your behalf that you do not want them to be doing. So we look today at password security in general. We look at guidelines for choosing passwords, what you should not do, what you should do, and why. So social media account hacking is useful for people who want to do this and who want to get access to your information, because your information on a social network or a social media platform represents everything about you. It represents your name, your location, where you were born, for example, who your friends are. And so it's very easy for a person who gets access to this information to reconstitute a personality or a person who is very much like you, who looks like you on paper, and who can do things on your behalf, and quite likely things that you do not want them to be doing. For example, they could, on your behalf, post information on your social media platform. So for example, they could post information to say that you were pro-terrorist, for example, which might lead, for example, to the police and the Secret Service coming to pick you up, which would be very unpleasant. You could get, for example, spam email, which would then be very annoying, because what happens is that you not only get spam email, but all of your contacts get the spam email, which is very, very annoying, because they then don't know what is legitimate email from you and what isn't. And all of these are variants of identity theft that are just annoying. It can get even worse if people begin to use this information to create, for example, credit cards on your behalf and go to the bank and draw money on your behalf and cause you to get a bad credit record. So what you need, very essentially, is to choose a strong password. You need to choose a strong password that is difficult to guess and that has or comes from a pool of a really big number of possibilities. And we talk a little bit about why you need to choose a password from a really big pool of possibilities a little bit later on. The question that everybody asks is, how do I choose a good password that is strong and that is easy to remember? There are a few guidelines that you can use to choosing passwords, and you see this, for example, on some social media platforms that will require you to choose a password that has a number in it, a capital letter, for example, something from a lowercase character, and maybe some other symbol. And it's difficult because very often what you want to do is to just get through choosing the password, and what you tend to do is to choose something random that is difficult to remember afterwards, and then it becomes annoying to send a message to the social media platform to say, look, I've forgotten my password, can I have a hint or some link to reset my password? And what then tends to happen is that you choose something that is easy to remember and that you write down maybe on some piece of paper that you carry around with you, which is a bad idea. What you want to do is to pick something obscure, but something that you can remember. So for example, wooden cat could be written as WDN, a dash in between, and 4T, which would be something that would be weird enough for you to remember, but that has some acronym, or that has some clause, or that has some phrase that allows you to trigger your memory in order to remember the password. You want to pick something that is easy to remember, but you also want it to be complex for somebody else to guess. So for example, you want to pick a phrase that you will remember. And then maybe from this phrase, pick out all the first and last words of each, first and last characters of each word. Or maybe what you want to do is to substitute these letters with numbers or symbols that are similar to the character that you are replacing. So for example, you would replace S with 5 and maybe I with 1. Okay, you can use capital letters, for example, for some of the characters that you choose, or you could add in punctuation. Okay, so for example, if you had some sentence that said something like, so long and thanks for all the fish, okay, that would translate into what I have on the screen, which is SLATFATF in small characters. And then you could then transform that into a password that would be difficult for somebody else to guess, which would then begin with 5, for example, for the S, L, for example, in capital for the small L that you had in the first code that you designed, and so on. Asterisk or at for A, and so on. Okay, and then once you have a standard password like this, what you want to do is to be able to keep in mind this sentence so that you're able to remember the password whenever you need to use it. And then you have different platforms. So for example, you might have an account on Facebook, and then an account on Twitter, an account, for example, on Wikipedia, and so on different social media platforms. And what you want to do is not to be using the same password, even though it's difficult to guess for all of these different platforms. The reason that you don't want to do this is because if you find yourself in the unfortunate situation where somebody guesses the password for one account, you don't want them to be able to try that password on all the other possible accounts that you might have and be able to get access. So you want to make it that bit harder for them to hack into your account or into any of your social media accounts. So possible modification approaches that you can use to make this better without going to break a leg is, for example, modifying the password that we just defined for so long and thanks for all of the fish to, for example, something like F before the 5 and K after the F. And this would be, for example, your password for Facebook. And you could go on to do the same thing for other accounts, for example, for an eBay account that you have, for a Twitter account that you have, for a Wikipedia account that you have, and so on. Okay. What you should not do is pick, for example, your name in any form, even if you're going to spell it backwards, because attackers try all of these sorts of things. So, for example, it's very easy for Tom, T-O-M, to try M-O-T, and so on, and to eventually guess the password. You don't want to choose a common name like Sue or Joe. You don't want to choose a relative's name, names from popular culture, because those are all the sorts of names or all the sorts of passwords that attackers or hackers are going to try. You don't want to try an ID number because ID numbers are sequential, because ID numbers are finite, and eventually any attacker is going to hit on the ID number that corresponds to your profile, to your profile's password. You don't want to choose a single word, either preceded or followed by digits. So remember what I said about choosing a strong password. Now, words from a dictionary, or words that are names or that fall in popular culture, or that are, for example, easy to guess. So, for example, everybody has an identity number. Everybody, for example, has a social security number, and so on. This is how the state identifies you. Are easy for a hacker and make his job easier, because all he has to do is chuck this into some algorithm and keep trying until he hits the right one. So, for example, if we assume that you have an 8-character long password, to emphasize what I'm been trying to say, if you have an 8-character long password, okay, and you choose numbers only, what happens is that you have a set of 10 characters, for example, from which your password can come. Okay? That in terms of calculation means that 10 is going to be raised to the power of 8 because you have an 8 character long password. So that means in effect we have about 100 million possibilities. Now this seems like a really large number, but with very simple algorithms you can easily chunk through different numbers of possibilities and sometimes even in as little as 5 minutes hit on the right password. So you don't want to choose these sorts of passwords. If you choose, for example, lowercase alphabetic characters, you have 26 possibilities. Raised to the power of 8 puts you on the order of about 2 billion characters. Seems like a lot, but because the pool is unique, it's uniform, it's easy again to compute the password. This is something that you don't want to do. What you want to do is use a combination of all of these characters. So if you're choosing characters from numbers, from lowercase alphabetical characters, from full alphabetical characters, and so on, from printable symbols, what happens is, for example, at the very bottom that you can see highlighted in red, you suddenly have a possibility of 6 trillion characters, which is a lot more than what we had initially of 100 million characters. And then it makes the attacker's job even more difficult. Now it gets even better. If we have a password that has 9 or 10 characters long, that is 9 or 10 characters long, then it gets even harder. We are talking about quadrillions of characters that the attacker or that the hacker has to go through in order to eventually guess your password. So we hope that it makes his job difficult enough that he doesn't want to spend the time to calculate the password. But because he doesn't want to spend the time to calculate the password, we then need to be careful about other mechanisms for protecting your data. So in the next lecture, we're going to talk about access control. We're going to talk about this because, as I said before, social media are a great platform for sharing information, and information needs to be protected, otherwise it will be used in ways that you do not want it to be used.